Yes.
3, 2, 1.
Hi, my name is Ayesha Amjad, and I'm the AI Product Strategist at Astera. And our topic for today is memory for AI agents. The memory is a very important component for the AI agents, in addition to, of course, tools and functions. Now, the memory is important because without the memory component, an AI agent or an LLM agent is unable to hold coherent conversations or, for example, perform complex tasks or learn from the experiences. Memory in LLMs itself or LLMs in general, the way they are built or the way they are created are stateless, meaning that they are unable to save any state that they're currently in, which means they're unable to know what was the previous thing that they were supposed to do, what was the previous thing or what was the previous interaction that they had, what is the current interaction that they're having, what's the future interaction is going to be, or the user that the LLM is interacting with, what kind of user it is, what kind of preferences that particular user has. Now, to understand that, one of the things that we have to understand is that almost all AI agents or all AI agent applications that we have today store something like a history, a conversation history. And what conversation history it is, when we talk about history, we're just talking about a series or a thread of messages between an AI and the user. So for example, let's say the user, the AI starts, let's take an example of a sales agent. The sales agent, the AI sends the first message or exchanges the first message by saying that, hey, hi, I'm sales agent at XYZ company, how may I help you? The user in return can say something like, hey, my name is 123 and I am interested in one of your products. And they can now have a series of conversation that may continue. And this series of conversation would have these exchanges between the AI and the user, continuous exchanges, and that forms a history or a thread of history. Now, almost all applications stores this kind of history. But to go from history to, for example, memory requires a deeper understanding of how human brain actually processes their conversations, their interactions, and stores them in the form of a persistent memory. Now, when we talk about memory, the idea is that, of course, it has different types, right? So, for example, for a human brain or for generally most of the intelligent systems, what essentially happens is that their interaction passes through, or the entry way for that interaction is a sensory memory. So, for example, I have an application that is used for scheduling patient appointments. It's an intelligent application, and I'm interacting as a user. I'm interacting with that application via a cell phone call, right? So it has voice assistance. For this particular application, the sensory memory is going to be that back and forth voice exchanges that it has with me, and of course the AI agent itself is going to have some kind of responses in return. So those kind of exchanges are sent or are the first layer or pass through the first layer, which is the sensory memory, right? They needs to be, of course, encoded, and the reason for encoding is because LLMs understand in the form of vectors, which are numeric vectors. We'll get to what vectors are later in the video. But that's the idea, right? From sensory memory, it actually forms into two different kind of memories: the short-term memory and the long-term memory. Right? And you can see here that all of these memories have this node coming out of it, which is called forgetting node. Again, we'll dive deeper into what exactly forgetting is. But similar to how human memories work, we also prune all the irrelevant memories, or for example, the duplicative or repetitive memories that are no longer useful or that do not have any impact on our conversations or on our experiences, are simply forgotten. So there's an algorithm in the AI agents as well that keeps a track of that. Right? So from the short-term memory, you basically drive the long-term memory. The short-term memory is your working memory. So in a particular session, let's go back to our example of the patient appointment scheduling agent, right? So in a particular session where I am the one who's calling and interacting with this AI agent, that particular session, that agent needs to retain all the important information that the user has provided it, but also needs to retain all the responses that AI agent itself has generated. So for example, let's say, throughout the conversation, I may be giving, as a patient, I will be, giving my name, my date of birth, my symptoms, where I live, and the AI agent, in response to all of my messages or my exchanges, would be recommending certain doctors to me, would be recommending time slots to me. So it needs to retain that information as well. That's the working memory that the AI agent needs to maintain throughout that single session conversation that is having with the user, right? And from that working memory, or from that short-term memory, you basically drive what we call the long-term memory. Now, long-term memory itself has its own types. So the first type is the explicit declarative memory type. And the second is the implicit non-declarative type. Now, in the explicit, it further divides into semantic and episodic. When we talk about semantic memory, it's basically facts. So any facts, for example, let's say the semantic memory could be, in fact, let's talk about the episodic first, right? So the episodic memory could be that, hey, the agent's experience with the user, that's episodic. So let's say, for example, a user says, the way episodic memory would be stored, that the user has asked me to cancel their subscription for the next month. Whereas the semantic is a fact or a knowledge that, hey, cancel the subscription for the next month. So that's the major difference between episodic and semantic. Semantic also makes sure to implement or to ensure the relationships between different messages or across conversations as well. We'll get to that in detail as well. The other one is the implicit and non-declarative kind. Again, it also divides into two, the emotional and the procedural. So let's talk about the procedural first. The procedural memory is all about how to, it relates directly to the database. So for example, if I'm building a knowledge base for a software tool, now how particular things can be done within the software tool is something that will be part of the procedural. So it could be like, for example, hey, how to send an email, or how to add an entry into the database, or how to manipulate or clean certain data in Python. So all these kind of how-tos are something that are part of the procedural memory. The emotional memory is the user's feedback. In most cases, the kind of preferences that user has. So emotional memory is one of the key memories that actually personalizes an agent or a chatbot in accordance to its user interaction with their interactions with the user. So it personalizes its interaction with the user by storing the user preferences, or what we call user persona, right? So this is a very important aspect of the emotional memory. Now, when we talk about user persona, let's take an example of almost every chatbot or almost every LLM application that you interact with, be it OpenAI's ChatGPT or Claude's or Anthropic's Claude. All of these have this comprehensive memory management system in place, because as I said, right, LLMs are stateless. They themselves have no recollection of any past exchanges that they have with the user. And of course, all LLMs also have a limited context window. So the kind of information that we are sending to that LLM in the form of context, so that it gives you very relevant answers and personalized answers, all of that is dealt via a very comprehensive memory management system. So let's take an example that, hey, I'm interacting with one of these applications. Let's say maybe, OpenAI's ChatGPT. And I start by saying that, I love C#. That's one of the messages that I have sent to the GPT or to maybe Claude in one of my interactions, that I love C#. Now, this is saved as a statement in the memory management framework of that application of that chatbot, that, hey, Ayesha loves C#. That's the fact, right? It is storing it as a fact. Now, further, to make sure that it is a working memory, or even ensure that it's a memory that serves the application or chatbot in the long term, to make the application personalized, so that later on, whenever I ask this application to generate code for me, it always does that in C#. It needs to identify the entities. So the entities in this case is Ayesha and C#. These are the two identities, right? And these two entities is going to create a relationship between these entities. So in this particular case, that relationship is love, right? So the entity is Ayesha, and the C# is another entity, and they are connected via this link, which is a relationship link. So Ayesha loves C#, right? Now, and another thing that most of the AI applications do is that these relationships are stored with a timestamp. So, any recent conversation, any past conversation, the LLM needs to know, or the memory system needs to know exactly what recent memory to add to the LLM, right? So this is it was validated at a particular timestamp. Now later on, maybe, the next day, I sent a message that now I mostly use Python. right? I'm not saying that I no longer love C#. The only thing I'm saying is that now I mostly use Python, right? And this was something that I've added on the next day. Now, so one of the things that my memory management system is going to do is that it's going to invalidate a statement that Ayesha no longer loves C#, right? Or it basically becomes an invalid memory because, Python is a competing framework, is a competing language framework. And what it's going to do is that it's going to add things like another entity, Python, and is going to have this relationship between Ayesha and Python that, it likes. Ayesha likes Python now, right? And with the latest timestamp. And then at the same timestamp, this becomes invalid, that Ayesha loves C#, right? And at the same timestamp, this relationship has another link, which kind of, there's a break there, right? This relationship broke at this particular instance. So in this manner, all of these memory segments or all of these conversations that you have with the LLMs or with your chatbots in particular, they store the memories mostly in the form of graphical relationships, right? And they are stored in vector stores, right? So again, to take a deeper dive into episodic and semantic memory, take a look at this diagram, right? It's a graph. And in this graph, you can see that it has two parts to it. There is semantic memory and there is episodic memory. The semantic memory is a subset of episodic memory. And as I previously mentioned in one of the examples, that, what essentially happens is episodic memory is an experience that you recall, and semantic memory is a fact. And that fact is mostly, it comes together via these entities and, these relationships. So in the previous conversations, I could have multiple entities and relationships that I've built over time. And what it does is that using both semantic and episodic, it is slowly developing a user persona of me. So through just one example, I said that, hey, I like Python or I like C#. There could be other things that I've said over time that, hey, I prefer my responses in JSON format, or, I do not like informal tone, or I prefer straight facts. I do not like long-winded sentences. So things like that. All of these is part of the user persona and is stored via a combination of these two, semantic and episodic memories. So let's take a look at the working memory as well. Now, the working memory, what it essentially does is that, of course, it makes use of your semantic and episodic. It's very important for that working memory to make sure that in every conversation that's happening, it keeps on building the semantics and the episodic memory on the go, right? So going back to the example of patient scheduling agent, I may say things like, hey, this is my name, so my name is stored as an entity. I can say that, hey, I live in a country A, then country A is stored as an entity. I can talk about my symptoms, that, hey, I have headache and I have fever. So the symptom itself is going to be an entity. And between these entities, there are going to be relationships. So from my name to all of these different entities, it's going to establish the relationship, and that relationship becomes part of your working memory. So what working memory does is that it has certain observations, whatever the current observation is, and it also has certain goal that it needs to achieve. And that goal could be, hey, my goal as an agent, as a patient scheduling agent, my goal is to schedule an appointment for this patient that is talking to me. And my current observation so far is that this patient's name is Ayesha. Her age is 28 years old, and she has a headache and a fever, and she would like a general physician, and so on and so forth. So all of this observation that it is getting, or it is storing, or via these exchanges with the patient, it is adding that as part of its working memory, but also in its semantic and episodic memory, right? And then based on whatever decision it takes, it takes an action to generate the next response. And that next response could be, hey, so I'll send you an email for your appointment, or hey, I'm scheduling an email, or hey, I'm informing the doctor, and so on and so forth. So that's how these memories generally work. Now, how within a conversation, what essentially happens is, let's say at time t, whatever new event that we currently have, I want to recall a previous event, a previous message, or any previous experience, any previous fact. I want to recall that. And if you take a look at this entire diagram, this is very similar to the neural networks, especially the recurrent neural networks, right? So if you do a quick search, you'll see how exactly recurrent neural networks works. But the idea was that there are different pieces of information. So n minus 4, n minus 3, n minus 2, all of these are pieces of information that our system is storing about that user, right? Or about that conversation. And at the present conversation that it needs to generate whatever response, it needs certain memory from the past. It needs to recall certain memory from the past. And to recall this, it is going to use what we call distance formulas or distance algorithms. And these distance algorithms could be, for example, cosine similarities or Euclidean or Manhattan and so on and so forth. So it can use all of these distances to recall the most relevant or the most semantically similar memory. And here you can see at the bottom that this is being stored in a database. Now, what kind of database it is, that is something we need to understand. So the database that we're talking about is a vector store, right? So let's take a deeper dive into how that works. So let's say a user input comes in. In my case, I'm saying that I have salad for lunch every day, but I'm still not losing weight. This is my response, right? And of course, I'm assuming that I've had conversations with my agent previously. This is my health agent. And I've had these conversations with my agent previously, so it has some information in its memory. So I begin by saying I have salad for lunch every day, but I'm still not losing weight. Now, what happens is this user input first converts into a vector, right? The vector is a numeric representation of my words. And from the vector, this is updated into the database, or this is added into the database, right? Now, this database, then this database is my vector store. So you could have any vector store. For example, you're using, let's say, PG vectors, or you're using Pinecone, or you're using, the maybe Neo4j. It's all these different kind of vector stores you may use. And my question then has a similarity score with my matching conversation previously, or with its own knowledge base. And based on a relevancy score, it is going to the relevancy score is basically going to fetch all the relevant information that it has in its knowledge base, or that knowledge base could be external knowledge base, where we talk about the procedural memory, or that knowledge base could be intrinsic, your long-term memory itself, your previous conversations that you've had with this agent. So based on that, it's going to fetch certain words, and then it's going to consolidate it, of course, based on the probabilities. After consolidating it, this is where your memory call happens, right? After consolidating it, it's basically going to give you an output, right? And here you can see that there is also something called a forgetting curve, right? So previously, in just a few slides ago, we discussed about the forgetting mechanism. So there is an entire forgetting algorithm itself that makes sure that only the least relevant memories, or only the least relevant information is pruned from this vector store, right? So that's entirely how it works. So to conclude everything, the entire idea around memory management, memory storages is the ability to not only transform the history, which is simply the conversation history, which is simply the exchange between the AI agent and the user, not only take that, transform it into a memory in the form of semantic memory, episodic, procedural, and so on and so forth. So not only store that, but to store that, it also needs proper databases, knowledge bases, the mechanism to store that data. And when we take a look at this diagram, all we're saying is that when we have a short-term memory, you need a memory module right there and then. So it's going to be immediate, right? It can be an in-memory system. It can be right there as your encodings, right? You could use some kind of tools here. You could use maybe some kind of an MCP here that makes sure to take all of this conversation history, or all of this back and forth exchanges between the AI agent and the user, and converts it into or maybe create summaries out of it, maybe create relevant facts out of it, and then only pass those to the LLM, so that it does not, number one, go out of the context window, but also makes sure that all the relevant information is passed to the LLM so that it can give you relevant responses or very coherent responses. So that's the short-term memory. But when we talk about the long-term memory and its use in its storage, you need something like an entire knowledge base. You need vector stores in particular for that. That vector stores could be your relational vector stores, or or it could be your graph vector stores. So a lot of the memory management systems that we have today use graphical structure, because to build the relationships between the user and its conversations, but also to build relationships across the messages, you need a graphical structure or a graphical database to store these kind of memories, so that they are used, or they can be used to personalize the chatbot. They can be used to provide coherent and relevant responses, but at the same time they can also learn from their experience of interacting with the user, interacting with the environment, and produce most efficient and accurate responses while being in their context window. So that's about it for today.